Let's talk about the areas of some basic shapes. I'll start with the area of a rectangle. That will be all I know. And let's see where we can go from there. So, if I have a rectangle that has sides A and B, then the area of this rectangle is given by A times B. Right. Now I could cut this rectangle into two halves in many ways. One way would be to cut it along this side, or I could cut it along this side. I could also cut it along the diagonals. Let's do that. And yes, I've just split this into two halves. I mean, these sides are the same, these sides are the same. This side is common between the two parts. The two parts are identical, meaning they're just two halves. And I'm interested in only one of the halves. Well, this half happens to be a right triangle, and this also happens to be half of the original rectangle. So the area of a right triangle is half of A times B. If I call B the base and A the height, then I can say that the area of a right triangle is half of base times the height. And notice that the height is the perpendicular distance from the base to the opposite edge. If I take this to be the base, then the height again is the perpendicular distance from the base to the opposite edge. And it'll become clear in a moment why I'm describing height in this way. So, for example, if I have this triangle, what's the area of this triangle? If I take this to be the base, then I can draw the height. And this is base B. Well, for the sake of making things easier, let's call this part A. Let's call this part C. This is a right triangle. This is a right triangle. And I know the area of a right triangle. That's half times the base times the height. So the area of this part is half times A times the height. The area of this part is half times the base times the height. So, and the area of the total would just be the sum of the two. And I can write this in a better way. I can take half of h common, and so the area can be written as half of h times a plus c. Well, a plus c. Well, a plus c, that's just the whole base. So once again, we have half of the base times the height. So we're doing well. But what about this triangle? I mean, sure, if I call this the base, then I could draw the height like this. Then the area would be half times this base times the height. But if I am adamant that I want to use this as the base, can something be done about it? Oh, yes. I could just extend the base like this, and again draw the height like this. Now, this whole is a right triangle. This bit is a right triangle. This bit we're interested in is not. Let's see. Let's call this part the B, base B. Let's call this C. I know the area of a right triangle. That's half of C base times the height. Well, this is also a right triangle, this whole triangle. And the area of the whole triangle is, well, the base is C plus B and the height is H. So, and the area of the bit I'm interested in is this. So if I take away this bit from the whole, I'll be left with the area of interest. This is this area, and I can take it away from the whole. Half of C times H. Let me just write it down over here. So this is half of H times C plus half of H times B. And I'm taking away this bit, half of H times C. Well, this cancels out this, and I'm left with half of H times B, which again is just the base times the height. So the area of a triangle always comes out to be half times the base times the height. And once we have a triangle, we can do quite a lot of stuff. I mean, look at a parallelogram. So the opposite sides are parallel and equal in length. Let's call this B. So in the same way as a rectangle, I could divide this into two halves by cutting it across the diagonal. I could also draw the height from the base like this. And since these two triangles are the same, the area of one of these is given by half times the base times the height. So the area of one of the triangles is half times the base times the height. And this is just the same. So the total is just twice that. And that just leaves me with base times the height. So that's the area for parallelogram. Similarly, for a trapezium, if these sides are parallel, this is A, this is B, and I could draw the height again, H, and again I could cut it into triangles, and so the area of this triangle is half of B times H. The area of this triangle is half of A times H, because A is the base, H is the height. So half of A times H. Again, I could take H by 2 common, and I could write it down as half H A plus B. So the area for trapezium is the sum of the parallel sides times the height times the half. I mean, from triangles you can even get the area of a circle, but that gets a bit complicated. So I'll just leave it at that.